Next, balancing of the redox reactions. So, in order to balance the redox reactions, we have two methods. One is ion-electron method. The second one is oxidation number method. These are the two methods that are existing to balance any redox reaction. Now let us discuss about the balancing of the redox reaction through ion-electron method. So ion-electron method. This ion-electron method is applicable if ions participates in the redox reaction. The best example is, let us say KMnO4. When KMnO4 is used in any reaction, for balancing of the redox reactions at present we follow two methods. One is ion-electron method, the another one is the oxidation number method. So first let us discuss the balancing of the reactions through ion-electron method. This method is commonly employed to balance the reactions in which ions participate. For example, let us say KMnO4. When KMnO4 is used in any reaction, it will always act as the oxidizing agent, because in this KMnO4, the oxidation state of the central atom, manganese, is +7. Therefore, it will always try to gain the electrons. Hence, it will always act as the oxidizing agent. Next, when KMnO4 is used in any reaction, first it will undergo ionization into ions K plus and MnO4 minus. Therefore, this MnO4 minus ions will participate in the reaction to oxidize some other species. Therefore, the active species from KMnO4 is MnO4 minus. Next, let us say some other species we have taken. Let us say sodium sulfite. We have taken the sodium sulfite. When sodium sulfite is used in any reaction, first it will split into ions, sodium ions and sulfite ions. Those sulfite ions will act as the electron suppliers. So here sulfite means SO3 2-. Here if you observe the oxidation state of the sulfur here, its oxidation state is +4. Its oxidation state is +4. Since sulfur is in +4 oxidation state, so it can lose certain number of electrons to the MnO4 minus. Therefore, MnO4 minus will act as the oxidizing agent, SO3 2- will act as the reducing agent. Since MnO4 minus and SO3 2- react with each other, in this reaction MnO4 minus will gain electrons, SO3 2- will supply the electrons. Next, this reaction, it can happen either in the acidic medium or in the alkaline medium. Therefore, in order to show the presence of the acid or alkali, so just use any particular acid like H2SO4 or some other acid. Next, that side we have to show the products. Now, I am representing the redox reaction between MnO4 minus and SO3 2-. Now the reaction is taking place in the acidic medium. In acidic medium, KMnO4 will always reduce to Mn2+. Mn2+. Since it is gaining the electrons, therefore SO3 2-, sulfite ions have to undergo oxidation. If they undergo oxidation, sulfite will be always oxidized to the SO3 or SO4. SO4 2-. This is sulfite, this is sulfate. Next, now we want to balance this reaction through ion-electron method. In the ion-electron method, first identify the oxidation state of each and every atom participating in the reaction. Here, the oxidation state of the manganese is +7. Oxidation state of the oxygen is -2. Oxidation state of the sulfur here is +4. Oxidation state of this oxygen is -2. H+, it is a monoatomic ion. Therefore, the charge that is shown here itself will becomes the oxidation state. Next, manganese, it is also monoatomic ion. Therefore, the charge that is shown here itself will become the oxidation state. Next, sulfate. Here, the oxidation state of the sulfur is +6. The oxidation state of the oxygen is -2. So, first identify the oxidation state of each and every atom that is participating in the reaction. Then compare the oxidation state of the one particular atom from the reactant side with the product side. Here +7, here +2. Therefore, in case of the manganese, there is change in the oxidation state. How that oxidation state is changing? +7 to +2. +7 to +2 means decrease. Decrease of oxidation state always represents reduction. Always represents the reduction. For sulfur, see again there is change in the oxidation state. Here what type of change that is happening? Here +4 to +6. +4 to +6 means increase of oxidation state. Increase of oxidation state always represents the oxidation. Therefore, in this reaction, the manganese is undergoing reduction, sulfur is undergoing oxidation. Since manganese is present inside the MnO4, therefore we can say entire permanganate is undergoing reduction. Since sulfur is present inside SO3, therefore we can say entire sulfite ion is undergoing oxidation. After identifying the species which are undergoing oxidation and reduction, the entire reaction has to be divided into two parts. First part is called oxidation half reaction. The second part is called reduction half reaction. Therefore, how to divide this entire reaction into two parts? First, identify the atom which is undergoing oxidation. Here, sulfur is undergoing oxidation. Therefore, the sulfur plus the other atoms present in the molecule has to be separated. Entire molecule has to be separated. Similarly, this side, sulfur has gone into the sulfate ion. Therefore, you separate the entire sulfate ion from the parent reaction. Sulfite, from the left side we have separated the sulfite, from right side we have separated the sulfate. Put the arrow between them. Therefore, this is called one half reaction or one fragment. Since in this fragment, since there is involvement of oxidation, therefore it is called oxidation half reaction, OHR. Similarly, the second part of the reaction. Here MnO4 minus, here manganese is undergoing reduction. Since manganese is present inside the MnO4, therefore you separate the entire MnO4 from the main reaction. So MnO4 minus. This side, manganese is getting converted into Mn2 plus. Therefore, Mn2 plus. Therefore, this is here manganese is undergoing reduction. Therefore, entire reaction is called reduction half reaction. One is called oxidation half reaction. The another one is reduction half reaction. Like that, when the given reaction is observed, then after identifying the oxidation and reduction, the entire reaction has to be fragmented into two parts. Oxidation half reaction and reduction half reaction. You name them as reaction 1. After fragmentation, then step by step, each and every atom has to be separately balanced. In the first step, you balance all the atoms except oxygen and hydrogen. Here in this first half reaction, here we have SO3, here we have SO4. In the first step, identify only the atoms other than oxygen and hydrogen. Other than oxygen and hydrogen means sulfur. Here one sulfur and here one sulfur. Since the sulfur atoms have already balanced, you carry the reaction as it is without any change. Similarly here, in the second half reaction also, in the first step, balance all atoms except oxygen and hydrogen. Here except oxygen and hydrogen means manganese. Here the manganese atoms are already balanced, therefore you carry the reaction as it is. This is the first step. That means first step is the balancing of the heteroatoms except oxygen and hydrogen. Next, second step. After balancing the heteroatoms, in the next step, balance the oxygen atoms. For balancing of the oxygen atoms, first count the oxygens. Here you see, here 3 oxygens, here 4 oxygens. That means here one oxygen atom is less. One oxygen atom is deficient. Here 4 oxygens, here 0 oxygens. Therefore here 4 oxygen atoms are deficient. Therefore the oxygen atoms have to be balanced by adding suitable number of water molecules to the deficient side. For addition of the water molecules, you count the oxygens. First find the difference. Here 3 and 4. Here deficient of oxygens are present. How many oxygens are deficient? Only 1. So for the deficiency of each oxygen, add 1 water molecule. That means here we have to add 1 water molecule. So SO3 2 minus plus add 1 water molecule. Now SO4 2 minus. Similarly, here also one side 4 oxygens, the other side 0 oxygens. That means one side is deficient of the 4 oxygens. Therefore, add 4 water molecules to the deficient side. So now in both the half reactions, we have balanced the oxygen atoms. After balancing the oxygen atoms, then we have to balance the hydrogen atoms. Now count the hydrogen atoms in both the half reactions. This side 2 hydrogens are present, this side 0 hydrogens. Similarly here 8 hydrogens are present, here 0 hydrogens are present. Therefore how to balance the hydrogen atoms? For balancing of the hydrogen atoms, first observe the skeleton reaction given to you in the problem. In the skeleton reaction, if they would have shown H plus ions, then we have to understand that this reaction is taking place in acidic medium. If the reaction takes place in acidic medium, the hydrogen atoms have to be balanced through one particular procedure. If the reaction takes place in alkaline medium, the reaction has to be balanced through a different procedure. So first here, since anyway the reaction is taking place in acidic medium, you balance the hydrogens through one particular procedure. So what is that procedure? Here in acidic medium, the hydrogen atoms have to be balanced by adding H plus ions to the deficient side. Here which is deficient side? This is. Therefore here we have to add the H plus ions. How many we have to add? 2 H plus ions, because this side 2 extra hydrogens are present. So now hydrogens got balanced. Similarly, observe this reaction. Here 8 hydrogens are extra, here 8 hydrogens are deficient. Therefore, add 8 H plus ions. Eight H plus ions. So that means now in the first half reaction as well as in the second half reaction, the hydrogens have been balanced. Next, see now you see in the first step we have balanced the heteroatoms. In the second step we have balanced the oxygens. Next we have balanced the H plus ions. So after balancing all atoms, now we have to balance the charge. For balancing of the charge, you count the charge on each side of each half reaction. Here total 2 units of negative charge is present. 2 units. Here what is the total charge? Here 2 units of negative charge, 2 units of positive charge. Therefore net charge here is 0. Here net charge here is 2 units. 2 units. That means here 2 units of negative charge, here 0 charge is present. Now we have to balance the charge. Balancing of the charge means we have to see that the total negative charge present here must be equal to total negative charge here. Or if positive charge is present on one side, that positive charge has to be equalized to the other side also. Therefore, in this case, 2 units of extra negative charge is present, here 0 charge is present. For balancing of the charge, always we have to add the electrons. Always we have to add electrons. We should not subtract the electrons. We should not add the protons or any other species. Only by adding electrons, the charge has to be balanced. Here 2 units of extra negative charge is present. Therefore, here we need 2 units of extra negative charge. Hence, add 2 electrons. For each negative charge you require, add 1 electron. Here we need 2 negative charges. Therefore, add 2 electrons. SO3 2 minus plus H2O. Here SO4 2 minus plus 2H plus 2 electrons. Now you count the total charge here and this side, they will get balanced. Next, similarly here 1 unit negative charge, here 8 units of positive charge. Therefore net charge here is 7 units of positive charge. Here 2 units of positive charge. Now this side some amount of positive charge, that side some amount of positive charge is present. Now they are different. Therefore those two positive charges have to be balanced. Now how to balance? Here for balancing of the charge, compulsorily we have to add electrons to the suitable side. Now to which side the electrons have to be added to be now? Here this side. Because here 7 units of positive charge, here 2 units of positive charge. Therefore continuously add the electrons till this side positive charge become equal to that side positive charge. Therefore how many electrons are required? Just a difference, 5 electrons. MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2. Therefore now see the charge this side and the charge that side are one and the same. Therefore in this half reaction charge has been balanced. In this half reaction charge has been balanced. Next step, after balancing the charge in both the half reactions, now we have to see that the number of electrons added into each half reaction must become equal to each other. Here we have added 2 electrons. Here we have added 5 electrons. That means in these two separate half reactions, different number of electrons are existing. Now we have to equalize that number. For equalization of the electrons in both the half reactions, you select any quotient and multiply the entire reaction with that quotient. So instead of selecting any one quotient, you simply exchange the number of electrons that you have added into the two half reactions. Here we have added 2 electrons, therefore multiply the second reaction with the 2. Here we have added 5, therefore multiply the first reaction with that 5. That means with this 5 you have to multiply this reaction. With this 2 you have to multiply this reaction. Therefore by exchanging the electron number, I am multiplying the opposite reactions. Therefore first I multiply the first reaction with this 5. The reaction becomes 5SO3 2 minus plus 5H2O gives 5SO4 2 minus plus 10H plus 10 electrons. Similarly, with this number, you multiply the second reaction. Now, 2MnO4 minus plus 16H plus 10 electrons gives 2Mn2 plus 8H2O. Now, we have equalized the electron number in both the half reactions. After equalization, then the two independent reactions again they have to be added together and we have to derive the net reaction. For that, to derive the net reaction, now just represent the two reactions one below the other one. 5SO3 2 minus 5H2O gives 5SO4 2 minus plus 10H plus 10 electrons. There 2MnO4 minus plus 16H plus 10 electrons gives 2Mn2 plus 8H2O. Now add the two reactions with each other. During the addition, if any similar term appears this side and that side, we can cancel that similar term. Therefore 5SO3 2 minus. Next 2MnO4 minus. Next here 5H2O, here 8H2O. So all these 5H2O and here 5H2O will get cancelled. Here only 3H2O will be left. Similarly, electron number, this side electron number and that side electron number will get cancelled. Next here 16H plus, here 10H plus. Out of this 10 and this 10 will get cancelled. Here 6H plus will be left. Next here 5SO4 2 minus plus 2Mn 2 plus 3H2. This is the net derived reaction. After deriving this reaction, now if you count the number of atoms, if you count the charge, if you count the electrons, every type of the species have been equalized with each other from the reactant side to the product side.